Hello everyone, welcome to new class. Today's class is about the problems on parallel plate capacitor. Let us go through the problem. A potential difference of 1000 volt is applied across the plates of a parallel plate capacitor. The plates are separated by a dielectric of thickness 2 mm and relative permittivity of 5.5. Area of each plate is 350 centimeter square. Calculate the capacitance. Second one, the electric field intensity. Third one, the electric flux density. So first of all, write down all the data given. Here voltage is given, area is given in centimeter squares. So convert into meter square. For that multiply with 10 raised to minus 4. And the dielectric thickness is given as 2 millimeter. That is 2 into 10 raised to minus 3 meter. And epsilon r is given as 5.5. Epsilon 0 we know 8.854 into 10 raised to minus 12 farad per meter. The first question is to find the capacitance. And the capacitance equation is C is equal to epsilon 0 epsilon r into A by D. Here all the data are given, so we can calculate capacitance very easily. That is C is equal to epsilon 0 epsilon r into A by D. Epsilon 0 epsilon r area and the thickness also given. After calculating we get 852.19 into 10 raised to minus 12 farad. 10 raised to minus 12 is known as pico. So we can write 852.19 picofarad. Next question is to find the electric field intensity denoted by the letter E equal to V by D. Voltage is given and the thickness is also given, and we get 1000 by 2 into 10 raised to minus 3 as 5 into 10 raised to 5 volt per meter. The unit is very important in all the cases. The last question is to find the flux density. We know flux density D is equal to epsilon 0 epsilon r into E, or D is equal to Q by A. But here we don't know the value of Q. But we can find it. That is Q is equal to C into V. So either we can use D is equal to epsilon 0 epsilon r into E, or D equal to C into V divided by A. And we get the value of flux density as 24.348 into 10 raised to minus 6 coulomb per meter square. Let us do another problem. A parallel plate capacitor has a plate area of 20 cm square and the plates are separated by 3 dielectric layers, each 1 millimeter thick and of relative permittivity 2, 4 and 5 respectively. Find the capacitance of the capacitor and the electric stress in each dielectric if applied voltage is 1000 volt. So this is the case of a parallel plate capacitor with composite medium. And we have to find the capacitance of the capacitor. And here there are 3 dielectric layers. So the capacitance C is equal to epsilon 0 A divided by D1 divided by epsilon R1 plus D2 divided by epsilon R2 plus D3 divided by epsilon R3. And also we have to find the electric stress. Electric stress is nothing but the electric field intensity. Now substitute all the values. Epsilon 0 is 8.854 into 10 raised to minus 12. Area is given as 20 centimeter square, that is 20 into 10 raised to minus 4, whole divided by D1 is D1, D2 and D3 are given as 1 millimeter, that is 1 into 10 raised to minus 3. And epsilon R1, epsilon R2 and epsilon R3 are 2, 4 and 5 respectively. After calculating this, we get 1.864 into 10 raised to minus 11 farad. Next we have to find the electric stress in the material. For that, electric stress is E is equal to D by epsilon 0 epsilon R, and for that we have to find flux density. And to find flux density, we have to find the charge. So first find the charge on each plate, that is Q is equal to C into V. C is 1.864 into 10 raised to minus 11. Voltage is given and we get charge on each plate as 1.864 into 10 raised to minus 8 coulomb. Now find the electric flux density. D is equal to Q by A. And we get 9.32 into 10 raised to minus 6 coulomb per meter square. Now we have to find the electric stress with the relative permittivities of 2, 4 and 5 separately. First find the electric stress with epsilon R1 equal to 2. That is E1 is equal to D by epsilon 0 epsilon R1. D is 9.32 into 10 raised to minus 6 whole divided by 8.854 into 10 raised to minus 12 into epsilon R1 is 2. And we get 5.26 into 10 raised to 5 volt per meter. Now find electric stress with epsilon R2 is equal to 4. And substitute epsilon R2 as 4, we get E2 as 2.63 into 10 raised to 5 volt per meter. Now find E3 with epsilon R3 equal to 5. That is substitute epsilon R3 as 5, we get E3 as 2.11 into 10 raised to 5 volt per meter. Thank you for watching the video. If you like the classes, please like, share with your friends and also subscribe my channel.